like to talk a little bit about the design for manufacture. A lot of the entrants will be using thermoplastic and a lot of the designs will be injection moulded. The judges will be looking that the part has been designed correctly. There are some rules to consider when constructing with polymers. First of all, look at the wall thickness. It needs to be as thin as possible. Then, the wall thickness needs to be uniform in its distribution. If you're adding ribs to the part, for stiffening for example, then the design needs to be plastic-like. Where possible, avoid flat surfaces and make sure that the design is suitable for metal and plastic if you're combining the two materials. Consider gate position during construction. What I mean by gate position is, where will the plastic be injected and will it fill the tool correctly? Design the part considering the method of processing that you're going to use. Will it be injection moulded? Will it be vac formed? Or will it be rim cast? Avoid undercuts if possible, and also avoid mass accumulation. Corners and edges should be designed with a radii, otherwise it creates an area of weakness. If the part's to be injection moulded, use sufficient draft angles to release the component from the tool. Design holes and cutouts in a plastic-like manner. Use a suitable screw design for each plastic material, and also don't make tolerances smaller than necessary. Try to keep the wall thickness distribution as uniform as possible. As you can see from the slide, the top part is a poor design and the bottom is good design. If you are to change thicknesses, make sure that the part flows correctly. When designing ribs, first of all, add a radii at the corner and make sure that the rib is the correct thickness. You want to avoid mass accumulation where possible, and if necessary add a design groove. Avoiding flat surfaces. As you can see on the slide, having a large flat surface on the component will give possible warpage when moulding. A good design is to add either a convex or a concave flat area. Consider the gate position. If the part is injected in the wrong area, it may not fill the tool, or you may get possible voids in the component, leading to areas of weakness and fault. Design with processing in mind. If the part's going to be injection moulded, it needs to be designed in that way. If the part's going to be vac formed, it needs to be designed in that way. What I mean by that is, if the part is to be lifted off a vac form tool, it's much easier and can be a much more simple component. If it's going to be injection moulded, you can have much more complex shapes, but you need to remember the design options in terms of undercuts, gating position and ribs, etc. Avoiding undercuts. Again, coming back to injection moulding, if the part is, if your component is going to be produced in an injection mould tool, then an undercut needs to be reduced, as the part will be difficult to get off the tool. Avoiding mass accumulation. Again, this is really an injection moulding problem. If your component has areas of mass accumulation, what I mean by that is if it has very, very thick sections, very, very thin sections, then you will create voids in the component, possible warpage and areas of weakness. And that will lead to a poorly designed part. Corners and edges designed with a radii. If your ribs or indeed edges of the part are designed without a radius, then it will be an area of weakness, and the overall component will not be very strong and therefore not be suitable for its application. Provide sufficient draft angles. Depending on your material selection and again your method of manufacture, if you're choosing an injection moulding method, you will need to produce a correct draft angle to remove the part from the tool, and this will depend on your material selection, i.e. polycarbonate will need much different draft angles to a nylon. Remember when you're designing cutout and holes, you need to also add draft angles to these. If you're injection moulding, a straight cutout will be very, very difficult to release from the tool, whereas a drafted cutout will slide from the tool freely. If you're going to add screws and bosses to the component, you also need to think about that manufacture. You'll probably need to rib the areas to be screwed, therefore increasing the strength of the part. Also, don't make any tolerances on the part smaller than necessary. Snap fits. If you're looking to produce snap fits, firstly think about the material, is the material suitable for snap fitting, i.e. will it break on its first snap? How many times does it need to be snapped on and off? The advantages of a snap fit obviously is that it's a temporary joint, it's vibration resistant, it's very fast and simple, and you can join different materials. The disadvantages obviously is that it requires an undercut, which as earlier isn't particularly favourable in injection moulding method, and also it provides an overmetic seal.